In this video, we are going to look at limiting reagent, and a limiting reagent is defined as a reagent that is used up completely during a chemical reaction. Okay, so now let's say we have a chemical equation where we have the reactants and we have the products. Now let's say reactant A is reacting with reactant B, producing product C and D. So if the number of moles of the reactants A and B, if their number of moles are not equal to each, and also the mole ratios, if they have different mole ratios, and also maybe they have different number of moles, we are expecting one of the two reactants to finish before the other one is finished. So the reactant that will finish first before the other one finishes, that is the one we refer to as a limiting reagent. So let's say if our A is a limiting reagent, what we are saying is this reactant will be finished during the course of a chemical reaction before the B finishes. So the other thing that we are saying is there will be leftovers of B. So the B is said to be in excess since there will be an reacted part. Okay, now maybe let's say let's have a picture where we want to make maybe samosas, and let's say here we have 3 pieces of meat. Then each samosa must have 1 piece of meat. So we can see that if we have to make, we can see that we are going to run out of the pieces of meat. So the pieces of meat will finish before the samosas are done. So therefore, the pieces of meat are referred to as the limiting reagent. So that's the picture that I wanted us maybe we have in mind. Now, from there, we also have to know that we may have questions like we can use a limiting reactant to find maybe the mass, the volume, concentration, or maybe number of particles of an unknown substance. Maybe let's have an example. Now we have an example. So if 225 grams of silicon tetrachloride react with 225 grams of magnesium, then the question is which reagent will be used up first. Now you can't use the mass if you are trying to determine the limiting reagent, because as we can see, the two have equal masses. The silicon tetrachloride has a 225 grams and the magnesium has also a 225 grams. So now, what is our first step to consider whenever we are dealing with a limiting reagent? So therefore, the first step that we need to do is we need to write the balanced chemical equation. So we can't do anything without a balanced chemical equation. So let's begin with a balanced chemical equation. Now we are going to use the word equation. We have magnesium plus silicon tetra. So now from the word equation, we can see that magnesium is more reactive than silicon. So magnesium will displace silicon, giving us magnesium chloride. Plus silicon. Now from there, let's write our chemical equation. So the symbol for magnesium is Mg, solid. Now for silicon tetrachloride, here we need to use the valences. So silicon, and since we have this word of tetra, whenever you see a tetra, that means 4. We have mono, which means 1. So mono, 1 like monoxide, di, 2 like dioxide, tri, 3 like trioxide, then tetra 4. So what this means is there are 4 chlorine atoms. So silicon tetrachloride can be written as like this. So silicon tetrachloride solid. Then here we are going to have magnesium chloride. So now magnesium, for us to write the chemical formula for magnesium, we need to look at the valences. So the valence for magnesium is in group 2, so it has a valence of 2. Chlorine in group 7 has a valence of 1. So if we interchange here, we can see that magnesium chloride has a chemical formula like this one now, plus silicon. So now after we are done writing the chemical, we need to make sure that this equation is balanced. So we need to check if our equation is balanced or not balanced. Now let's now check. So from the reactant part here, we can see that we have 1 magnesium. Then from here we can also see that we have 1 magnesium. So the magnesium is balanced. Let's check for silicon. So for silicon, we can see that we have 1. Then from this side we also have 1. Now let's check for chlorine. So for chlorine we have 4. Then here Cl we have 2. So now here we need to balance the chlorine. So what we are going to do is we are going to divide 2 must go into 4. So we need to divide 2 into 4 is 2. So this means that we need a 2 in front of magnesium chloride. So now we can see that now the chlorine now becomes 4. Now what this means is this is same as magnesium chloride plus magnesium chloride like this. Since we know that here we have 1, here we have 1, if we add 1 magnesium chloride plus another magnesium chloride, we have 2 magnesium chloride. Then we can see that from each part there are 2 atoms of chlorine. From each part there are 2 atoms of chlorine. So this is what it means by saying now we have 4. Now from there we can also see that now this time we also now have 2 atoms of magnesium. So even magnesium has changed from 1 to 2. So we can see that we need to also balance the magnesium on the reactant part. So 1 into 2 is just 2. So from there we can now see that our equation is balanced. So after balancing the equation, what we are going to do here, we are going to find the number of moles. So let's begin by finding the number of moles for each part. So magnesium has a mass of 225 grams. So is silicon. So let's find the magnesium, the number of moles for magnesium. So number of moles is equal to mass over molar mass. So since magnesium is just a pure element, we are going to find its relative atomic mass. So the relative atomic mass for magnesium is 24. So therefore, so what we are saying is relative atomic mass for magnesium is 24. Therefore, its molar mass is also equal to 24 grams per mole. So now, when finding the number of moles, do not use the number in front of a compound or an element. So this mole ratio 2 will be used later. So now let's substitute where there is mass. We have said that the mass for magnesium is 225 over the molar mass is 24 grams per mole. So we need to divide 24 into 225. This will give us the number of moles of 9.375 moles. So these are the moles of magnesium magnesium metal. Now the second one, we are going to find the number of moles of now silicon tetrachloride. So here we also have number of moles is equal to mass over molar mass. So the mass is 225 grams over, now we need to find the relative molecular mass for this one. So let's look at silicon tetrachloride. So mister, we can see that there is one atom of silicon, so times 1 plus CaO times 4. So silicon, the mass number for silicon is 28 times 1 plus chlorine 35.5 times 4. So 28 times 1 is 28. Now 35.5 times 2 is 71 plus 71, that is 142. So 142 plus 28 is 170. So therefore the molar mass is equal to 170 grams per mole. So here we have 170 grams per mole. So you can cancel this. So now 170 into 225, we have 1.324 moles of now silicon tetrachloride. So now after finding the number of moles for each, what we are going to do is, in order to now determine the limiting reagent, we are going to divide the number of moles by its mole ratio. So let's look at the mole ratio for magnesium. So the mole ratio for magnesium is 2, while for silicon, here we can see that there is no number, so this means that there is 1. So now we can divide. So here we are going to divide by 2, then here we are going to divide by 1. So you need to divide the mole ratio for each reactant, then divided by its mole ratio. So 9.375, then divided by 2, we have 4.6875 moles. Then this one, we know that any number divided by 1 is equal to that number, 1.324 moles. So now from there we need to compare the two. So the reactant with the smallest number of moles is our limiting reactant. So therefore we can now say silicon tetrachloride is a limiting reagent. And the reason is because the number of moles for silicon tetrachloride are less than those for magnesium. Okay, now let's have another example. Okay, now if 3.50 grams of zinc metal react with 2.50 grams of hydrochloric acid. So now determine the limiting reactant. Okay, so we have zinc plus hydrochloric acid So we know that from the hydrochloric acid we are just going to get the chloride, so we are going to have zinc chloride plus hydrogen. So whenever you react a pure metal with an acid, you are going to have a salt and the hydrogen gas. So the salt is zinc chloride and the hydrogen gas there. Then the symbol for zinc is Zn plus hydrochloric acid is HCl. Then for zinc has a valence of 2, while chlorine has a valence of 1. So if we swap, we are going to get zinc chloride. So we have plus hydrogen is the atomic key at RTP. Then from there we need to see where we need to make some balances. So we can now tell that we have one zinc from the reactant and one zinc from the product. So the zinc is balanced. Now let's look at the hydrogen. The hydrogen is not balanced and the chlorine is also not balanced. So what we are going to do is we can see that we have one atom of Cl here, then we have two atoms of Cl there. So what we are going to do is divide. So 1 into 2 is 2. So we need 2 in front of HCl. Or since there is one atom of chlorine in hydrochloric acid, so we need 2 molecules of HCl like this. So we need 2 molecules of HCl so that we have these 2 atoms and also these 2 atoms. And you know that if we add HCl plus HCl, we get 2 HCl. So this simply means we need a 2 in front of HCl. Now after we are done balancing the chemical equation, we can now proceed by finding the number of moles. So we are going to find the number of moles for each part. And we have been given mass. So let's find the number of moles for zinc. So number of moles, let me change the color. So the number of moles is equal to mass over molar mass. So number of moles is equal to, the mass for zinc is 3.05. It means 3.50 grams over. Now zinc is just a pure metal. The relative atomic mass of zinc is 65. So therefore the molecular mass is 65 grams per mole. So now we can divide 3.50 divided by 65. This will give us 0.05. 0.0538 moles. So these are the moles of zinc. Now number 2, we need to find the number of moles of hydrochloric acid. So number of moles is equal to mass over molar mass. So the mass for HCl is 2.50. Now here we have a covalent compound, so we need to find the relative molecular mass. So we can now see Mr is equal to, so HCl, you can see that we have one atom of hydrogen plus one atom of chlorine. So the mass number for hydrogen is 1 times 1 plus 35.5 times 1. 1 times 1 is 1 plus 35.5 times 1 is 35.5, which is equal to 36.5. So therefore the molar mass is equal to 36.5 grams per mole. So we divide by 36.5 grams per mole. So we can now cancel. So we can now divide. So we can see that 2.5 divided by 36.5. So we have 0.0618 moles. So these are the moles of HCl. Now upon reaching here, we need to divide the number of moles of each reactant by its mole ratio. So from the zinc we can see that we have 1, so we are going to divide with 1, and anything divided by 1 is equal to the same thing. So here we have 0.0538 moles of zinc. Then here we are going to divide by 2, since the mole ratio here is 2, so we divide by 2, So now let's do mathematics here. So this number divided by 2 is equal to 0.0342 moles. Okay. Now here, upon reaching here, we can now see that the first question, the limiting reactant is in. So therefore, the limiting reactant is hydrochloric acid, and the reason is simple, because 0.03 is less than 0.05, so that is our answer for this part. Now let's move on to the other party. So now for the other part here, we can see that we are trying to find the volume of the gas produced at RTP. So the volume of the gas, so the gas that was produced was hydrogen. So here what we are going to do, for us to find a volume, whenever a condition is given, volume is equal to number of moles multiplied by its molar volume. So we need to find the number of moles of hydrogen. So let's look at the mole ratio for hydrogen. So the mole ratio for hydrogen here is 1. So we are going to use now mole to mole in order to find the moles of hydrogen. So let's see here, we have HCl to hydrogen. The mole ratio for HCl is 2. The mole ratio for hydrogen is 1. The number of moles of HCl, we have it. And just a reminder, when after finding the number of moles, or after finding the limiting reactant, and you're asked to find the number of moles of another substance, make sure you use the number of moles of the limiting reactant to find the number of moles of a known substance. So here we can see that we can cross multiply. So 2 times x is 2x, then 1 times 0.03, we have 0.0342, divided by 2, also divided by 2. So x is equal to, so we have about 0.017 moles of hydrogen. So this principle is a mole to mole. So now we have found the number of moles of hydrogen, so we can now proceed. So volume is equal to, the number of moles is 0.017 times, now the molar volume, since the condition is RTP, the molar volume is 24. So now 24 times this number, this will give us 0.41 cubic decimeter. So that is the volume of hydrogen produced. And that's it for this video. Thanks for watching.